Hello students. Today we'll start the first unit, that is some basic concept of chemistry and its principle, part 1, class 11 science. Let's start. The objective of the lessons are importance and scope of chemistry, then nature of matter, law of chemical combinations, Dalton's atomic theory, atomic and molecular masses, and stoichiometry and stoichiometric calculations. Now, the first point, importance and scope of chemistry. If you're asked what is chemistry, chemistry is the branch of science that deals with the atoms, molecules, and their transformation. The scope of chemistry is this is the subject that help us to understand the properties of various matter in our surrounding. For example, the rubber, the glass, the diamond, the coal, the diesel, petrol, pesticide, greenhouse gases, all this matter have different properties. With the concept of chemistry, we can understand why this matter have different existence form, what is the special property, why the property exists in them, what is the atomic and molecular level arrangement in the matters, etc. The scope or advantage of studying chemistry is it helps us to understand better the chemical principle that can be used to design new synthetic materials having special magnetic, electrical or optical properties. You can modify the property, okay? For example, a rubber cannot attract a substance, but a magnet can. Now, if you know why the piece of magnet acquired that special property at molecular level, then you can arrange the atom of different element in such a way that it also start attracting, and chemistry help you to design such new substances. It also help us to create eco-friendly environment as it find the alternatives of environmentally hazardous refrigerants like CFCs, that is chlorofluorocarbon, and the one that is responsible for the ozone layer depletion in stratosphere. So with better understanding of chemistry, the chemically hazardous substances can be replaced with a safer alternative. Next we'll go for the matter. So you already know the definition of matter, that state anything that has mass and occupies space is defined as matter. Example, soap, pencil, then fruits, battery, water, etc. Physical state of matter. Basically in chemistry we deal with the 3 physical state of matter. You know about 5 physical state of matter, but here we will not consider the Bose-Einstein condensate and the plasma state. Here only we will deal with the solid, liquid and gaseous state of the matter. We also know that these 3 states of matters are interconvertible among each other. For example, you can change solid to liquid by heating, and again liquid to solid by cooling and condensing, then liquid to gas by heating, and the reverse process by cooling down the gas, solid to gas by sublimation, gas to solid by reverse sublimation. So each state of matter are interconvertible. Classification of matter goes as pure substance and mixture. Pure substance can further be classified as element, compound, and mixture is of 2 types, homogeneous mixture and heterogeneous mixture. Now we'll see each of this element, compound, heterogeneous and homogeneous mixture in detail. Now, what is an element? An element is obviously a pure substance that consists only one type of atom. For example, if you take a block of sodium, there you will get only sodium atom. Then copper metal block or copper spoon, you will get only copper atom. Same as silver, hydrogen, oxygen. So here in the formula also you see oxygen formula, oxygen gas formula is OT, O2. Here you are getting only oxygen atom. Ozone formula is O3. Only one type of atom is there. So any substance that contain only one type of atom are called element. Now compound is what? In compound you get two or more type of atom and these are chemically bonded. Okay. In compound you get two or more type of atom and these atoms are chemically bonded. For example, water H2O, ammonia NH3, sugar C6H12O6, then carbon dioxide CO2, etc. Next, we'll go for the mixture. Mixture contain two or more substance present in it, but do remember here among the substances you are not getting any strong chemical bond. Weak bond or weak attraction may exist there, but no solid chemical bond you will get in the mixture. Example of mixture are air, sugar solution, then mixture of pulses and stone, etc. Mixture is of two type, homogeneous mixture and heterogeneous mixture. Now see what is that homogeneous mixture. Suppose you have taken a glass of water and here you have added some sugar. Now after stirring well, if you taste a spoon of the solution, sugar solution from the top and another spoon from the bottom of the glass, what will be the taste? The taste of the solution will be same. Both the spoon will have the same taste. Okay, that means the composition is same throughout the solution. So such kind of solution where compositions are uniformly spreaded are called homogeneous mixture. In contrast, heterogeneous mixture is the one where you don't get the uniform composition of the substance present in it. For example, this is a mixture or you can say chana mixture. Here from this side, okay, from this part if you take a spoon, then you will be getting two nuts, some along with the other substances, other pulses and all. If you are taking the spoon from here, you are getting three nuts. So see the composition, this is a complete mixture but the composition is different at different part. So this is an example of heterogeneous mixture. Next, properties of matter. Every substance have two characteristic properties. One is physical properties, another one is chemical property. Now what is physical property? Physical properties are the one that can be measured without changing the identity or composition of the substance. For example, the melting point, boiling point, density, color, smell or odor, etc. These are the property where you need not to change the substance and the composition. Chemical properties are the one that require chemical change and here chemical reaction involved. For example, acidity, basicity, combustibility, then all kind of chemical reactions, decomposition, combination, etc. So in physical property you can measure it without changing the substance, and in chemical property it deals with the chemical reaction where changes occur. Next, whenever we talk about the property, this can again be subdivided into two types, that is qualitative and quantitative property. From the name only you can guess, qualitative property deal with the quality of the substance. For example, their smell, their appearance, the surface, the shine, luster, etc. And quantitative property deals with the quantity. That means you can measure it, you can give some number, you can give some figure and unit to this. Now, many properties of matter such as length, area, volume, etc. are quantitative in nature. That means you can represent them with some fixed value. It have two parts. One is numerical part, numeral part, that means one number along with the unit. For example, length of a room can be represented as 6 meters. See, 6 is the number and you are getting the unit. Here 6 is the number and m denote the meter, the unit which in which the length is measured. Okay. Now the unit again is of two type: English system or SI system and metric system. Metric system deals with the decimal representation and English system is a SI system. There are 7 basic or fundamental unit. That means they are the one which are the which can be represented alone. You don't need the help of any other unit to define them. But other than the 7, all other units are derived unit. That means if you are trying to present them, you have to take the help of this 7 basic fundamental units. Okay, so these are the basic unit. Now what are the 7 basic unit? This is very important table. First is length, SI unit is meter, symbol is m. Next is mass, unit is kilogram, kg, time second, s, electric current ampere represented with A, temperature, SI unit is Kelvin. Do remember, it's Kelvin, not degree centigrade. The symbol is capital K. Then amount of substance mole, MOLE mole, and the symbol is MOL. Then luminous intensity is candela. The symbol is CD. Luminous intensity means brightness. How much bright the light is. How can we measure? We can measure it in terms of luminous intensity. So these are the 7 basic fundamental unit. You have to remember this table along with their corresponding unit and symbol. Next, some prefixes that are used to calculate or to do the measurement in the SI system. The same table you will get in the book. I'll be highlighting few important SI system that you have to remember. This centi. Okay, if you have to represent any quantity in centi, in terms of centi, then the power will come as 10 to the power minus 2. Then milli for 10 to the power minus 3, micro for minus 6, nano for minus 9. Do remember 9 and n, nano, both are n, okay, starting with n. So nano is 9. Then pico 10 to the power minus 12. So this, especially the lower part, you have to remember. Next, this table was in the negative form, that means the power is in negative, that is 0.000 something. And next table is for the positive power. For example, hecto is 10 to the power 2, then kilo is very important, 10 to the power 3, mega 10 to the power 6. If it is minus 6, then micro. If it is plus 6, mega. To remember that. Then giga 10 to the power 9, etc. So this many, the upper part of this positive table you will remember. Okay. Let's see some numeral. One problem is given that convert the following into basic unit. We are given 28.7 picometer. Okay, now how to solve it? We know that 1 picometer is equal to 10 to the power minus 12 meter. So 28.7 picometer, you have to multiply with 10 to the power minus 12 meter. After multiplication, you will get your answer. Very easy. Next, if the speed of light is 3 into 10 to the power 8 meter per second, calculate the distance covered by light in 2 n second, ns. Ns means what? Nanosecond. Now, the time given is 2 nanosecond. Now, nanosecond and another unit, you see, it is given meter per second, and SI unit is what? Meter. So nanosecond, nano, you have to convert it into meter. So nano means what? 10 to the power minus 9. So it will be 2 into 10 to the power minus 9 second. That is the time taken to cover the distance. Speed of light given 3 into 10 to the power 8 meter per second. Now we know that speed is equal to what? Speed is equal to distance traveled by time taken. So distance traveled by light will be what? Speed of the light into time taken. Speed of light given 3 into 10 to the power 8 meter per second. Time taken is this one, 2 into 10 to the power minus 9 second. If you simplify, this will be your answer. Okay, 6 into 10 to the power minus 1 meter or 0.600 meter. Prefer to present your answer in this form, not in this form. Okay, this form is correct. We'll see this topic later. This is the scientific notation format. So if you note down, you will present your answer to up to this line. So that's all for today. Thank you.